Hey everyone, welcome to another explainer made by Forge College. Today, we're bridging the gap between EVM and SVM by breaking down the true mechanics of smart contract events. You know, it's a really crucial step in our track covering the transition from Ethereum to Solana. And honestly, it's one of the most fascinating pieces of the whole puzzle. I'm super excited to dive into this, so let's just get right to it.
So, in our previous checklist lesson, part of the From Solidity to Rust and Anchor course, we established a golden rule. You absolutely have to preserve observable contract behaviors during a migration. And when we talk about observing what a contract is actually doing from the outside, well, events are pretty much the loudest behaviors you have.
Here's our roadmap for today. We're going to cover events in the migration checklist, the difference between logs and contract storage, the safe and the postcard metaphor, the anatomy of a transfer, and finally, preparing for anchor porting.
All right, Section 1. Events in the migration checklist. Observable behaviors.
During a migration, there are a few things you absolutely must preserve. We're talking about emitted events, public storage layout, and your external API. Why does this matter so much? Because indexers and UIs usually reconstruct your app's state entirely from those logs. If you break the logs, you break the UI. And suddenly, your users think all their tokens just vanished into thin air. You really do not want that angry mob in your Discord, believe me.
Moving on to Section 2. Logs versus contract storage, where data actually lives.
To keep those observable behaviors intact, we first have to respect the hard semantic boundary between an event log and actual contract storage. It's a massive difference. While smart contracts can read and write to storage all day long, they are completely blind to event logs. Once an event is emitted, as far as the contract is concerned, it's just vanished into the ether. No going back.
When we look at this matrix comparing their properties, that divide becomes really clear. Storage writes are expensive, they alter persisted state, and they're strictly meant for on-chain logic, like access control. Log emissions, on the other hand, are much cheaper. Transient records meant purely for off-chain analytics and indexers. Basically, storage keeps your system secure, while logs just tell the outside world what happened.
Okay, Section 3. The safe and the postcard. Let's build a mental model.
I want you to imagine your contract storage as a heavy, locked steel safe sitting right inside the contract's room. You need explicit permission and a very specific key to open it. Whatever is locked inside that safe dictates the fundamental reality of your contract. It's secure, it's stateful, and it is the ultimate authority.
Now, event logs, they are totally different. Think of them as postcards pinned to a public notice board right outside the building. Anyone walking by, like an off-chain indexer, can stop and read them. But here's the kicker. You can't use a postcard to change what's inside that locked safe. The postcard is literally just telling the neighborhood what the person inside the room did. So what exactly are indexed parameters in this scenario? Think of them as brightly colored, slightly expensive stamps stuck onto that postcard. Sure, they cost a bit more gas ink to print, but they let busy indexers instantly spot the mail they care about from all the way across the street. If you index an address, an off-chain listener doesn't have to painstakingly read every single postcard on the board. They just scan for that bright stamp with their name on it.
Which brings us to a classic developer trap, especially when designing control flow. I want you to really think about this for a second. Can a contract look back at its own history? Can it actually make decisions based on events it emitted last week?
Absolutely not. Expecting a smart contract to authorize logic based on past events is like expecting a heavy steel safe to suddenly sprout eyes and read a postcard from last Tuesday. It's just impossible. If your on-chain logic needs to know that something happened, that information has to go in the safe. It has to go into storage. Never rely on events for on-chain control flow.
Section 4. Anatomy of an ERC20 transfer event.
Let's take our safe and postcard metaphor and map it onto the most famous event in all of Web3, the ERC20 transfer. Whenever you send tokens, this canonical event signature dictates exactly how that postcard is written out. As you can see, we have a from address and a to address, both of which are indexed, and an unindexed value.
Breaking it down, topic 1 is always the event signature hash. That's essentially the title of the postcard. Topics 2 and 3 get our bright index stamps for the from and to addresses. Meanwhile, the actual amount transferred, the value, sits right there in the unsearchable data payload. You can think of it like it's written on the back of the postcard, where you have to actually pick it up and decode it to read what it says.
Because we have those colored stamps, an off-chain listener can use node-level Bloom filters to efficiently pull a user's entire token history without ever needing to decrypt the actual transaction receipts. It literally just scans for the right stamps. It's incredibly efficient, and it's exactly why the ERC20 standards were designed this way in the first place.
Finally, Section 5, Anchor Porting, preparing your logs.
So how do we take this whole postcard system and get it ready for Solana? Well, we have to make sure our Rust-based anchor contracts emit the exact same shape of logs. This is the golden rule right here. If you change the event signature, or if you alter the indexed flags, you will instantly and completely silently break all your off-chain consumers. If your postcards look different, the neighborhood notice board is effectively useless to them.
I've got some homework for you before you move on to the next module. First, select 2 relied-upon Solidity events in your app. Note the exact parameter order and those indexed flags. Then, collect your off-chain filter code. You're going to need these concrete artifacts to verify your anchor port against later, just to make absolutely sure everything is a perfect one-to-one match.
To wrap things up today, I want you to think about the hidden dependencies in your own codebase. What postcards are your front ends secretly relying on to function right now? You need to map them out before you write a single line of Rust. To learn more about porting from EVM to SVM and to explore more deep dives, definitely go visit forge.college. This explainer was made by the team at Forge College, and we can't wait to see you in the next lesson where we actually build these events out. Happy coding!